College of Engineering, Karivattam, for organizing this webinar and also for inviting me. Because as you all know that this is a time of COVID and we are facing a lot of issues across the world, but also it has also given opportunity for all of us to embrace virtual learning and also approach learning in a different way. That is to access education through online classes and things like that. So we should try to make use of this opportunity to learn something and also to use the available e-learning resources in India and also in Kerala to improve our education sector. Okay, so anyway, we can go to the artificial intelligence and machine learning topic that I'm going to discuss here today. So let's see. As you all know that I am a mechanical engineer, but I decided to do a bit of research in self-driving vehicles as part of my job. So that's when I came across the opportunities in artificial intelligence and also in machine learning, which is actually a field more related to computer science. So that's the main reason I decided to take this particular topic for you guys, because um, you will be more familiar with artificial intelligence and machine learning and also with data analysis and programming, since you're coming from a computer background. Okay, so I hope everyone can see the screen and sharing here. Can everyone see that? Or okay, so let's see. Energy management of autonomous vehicles. So autonomous vehicle means a vehicle that's able to identify its surrounding and which is able to take decision on the basis of the information it's getting from its surrounding to drive the vehicle without having a driver to do that. So how does it do it? So the answer is quite simple, because vehicle is having a lot of sensors around it, and these sensors are obtaining data from its surrounding, and this data is actually used by an algorithm to compile and decide what kind of a reaction should be used when a particular amount of condition is happening to the vehicle. So in general case, before machine learning or data science was more common, what would have happened is we would have actually designed an algorithm and then used that algorithm to actually uh, run the car. But in today's world, because because of the improvement in machine learning and also in neural network, we are actually able to improve the process. Instead of creating an algorithm, what I have done in this case is created a neural network. So this neural network is actually kind of a self-learning technique, which means that if the vehicle is doing any error, then it will be able to understand that error, and then it will be able to correct itself and work towards an option where it will be able to react in a way that it improves every time it reacts to a situation. So now coming back to the slides, energy management of autonomous vehicle. So few things that we're going to discuss in this case is background, which means like what led to this problem and how was the problem formulated, what was the challenge and opportunities that this problem put forward. Now the background is, I hope everyone knows that autonomous driving strategy, which means that if a vehicle is having a fuel engine and the electric motor, then the usage of both of this energy should be optimized. So the main use of artificial intelligence that we do in this case is to optimize the usage of fuel and electricity in the vehicle. So what happens is we are trying to develop an integrated approach towards creating an efficient autonomous vehicle, which would actually help to create an efficient propulsion system. So you guys might think like, what is the role a computer engineer plays in this stage? So the role that computer engineer plays in this stage is actually he or she will lead the team in order to identify what kind of an algorithm is needed for the self-driving vehicle, to actually accept the data from its surrounding and also to use that data in a way that it will help the vehicle to react to its surroundings. So instead of just designing an algorithm or just designing a program, computer engineers will actually work to create a neural network which will be having the capability to learn and also to improve itself when it interacts with its surroundings. So the problem that we face is how can connectivity and automation be leveraged to reduce the energy consumed in a self-driving vehicle? Because when the vehicle is driving by itself without having any influence from the driver, it's actually the duty of vehicle to decide that how to use the energy. And that duty is actually done with the help of a algorithm or with the help of a machine learning technique. So it's very clear that from the current research happening across the world, there are two schools of thoughts. First one is having a self-driving vehicle will actually create some positive outcomes, like it will reduce the time taken for parking a car, it will improve efficient routing, efficient driving techniques, and also it will create a smooth running cycle for the vehicle. But then some people also say that self-driving vehicles create a lot of negative outcomes, which are traveling more faster, people not obeying the traffic rules, and also traveling by the people who might not need to travel, but they choose traveling because they don't have to drive. So all these questions lead to a formulation of a problem. That is to how do we find certain parameters which are available in autonomous vehicle sensor and use that to minimize the fuel consumed by vehicle. So when such a problem comes forward, in this stage, this is an opportunity for computer engineers and also people who have interest in data analysis, who have interest in developing machine learning, neural network techniques to actually analyze that what kind of data is actually being accepted in this case and how can you use that data to create an output that would actually help automobile and mechanical engineers to create a self-driving vehicle which will help to react to the immediate surroundings. So let's see what kind of parameters usually affect a vehicle. So first one is the route and the weather conditions. The second one is details of road characteristics, whether it's a hilly region, whether it's an urban area, rural area, whether the traffic is very high, and also the time, is it morning, evening, and then street conditions. Are the roads good? Are the roads having much issues? Traffic conditions, is it really busy on the road geometry, and also driver usage patterns. So these are the main parameters that affect how a particular driver will react to his driving conditions. And these are also the parameters that a computer engineer or a programmer can actually use to develop an algorithm that will help to optimize or that will help to create a system which can be used in a self-driving vehicle. So before going further, let's have a quick look at what are the different kind of self-driving vehicles currently available in market. As you can see, some people say that self-driving vehicles are divided into three categories. They are connected vehicles, automated vehicles, and autonomous vehicles. Currently in market, we have a lot of companies offering connected vehicles and a lot of companies also offering automated vehicles. So let's see, what level of automation are we discussing in this case? So it's pretty clear there's like 4 levels of automation, which starts from level 0, which means the current vehicles we have, no automation is there. And level 1 means it's function specific automation, which means like self-driving parking, and also some cars are having a cruise option. The level 2 is combined function automation, which means that for this particular level, the vehicle will be doing a certain amount of self-driving capabilities, but not to the full extent that is considered. The third one is a limited self-driving automation, in which case The vehicle will be able to accept information from the driver and take decisions based on that. The fourth one is fully self-driving automation, which is actually the stage that all automobile makers are trying to reach in the coming years. But to do that, we need to further improve our cloud computing and also artificial intelligence capabilities, because vehicles need to manage, run like 100 data nodes per minute and take a decision on based on that. So I'm not fully sure how long it will take to reach that level, but still optimistically all the researchers are actually trying to develop algorithms and programmings that will actually help to reach that particular stage. So this is actually how we classify the high level supervisory control to develop an optimization strategy for a self-driving vehicle. So as you can see, there is like two sections which can be used to create a self-driving vehicle. The first one is called a rule-based control, which is actually more towards algorithms. So in rule-based control, we will try to create algorithms which are like a specific, which creates a specific reaction to an action. So if the vehicle is going through a dark tunnel, then the algorithm will give a answer like the lights should be turned on. Similarly, if the vehicle is going in a rainy condition, then the algorithm will give a command saying that it's time to turn on the wiper. So rule-based controls are created in self-driving vehicles mainly as a reactive option, because algorithms are not able to learn, but machine learning neural networks have the capability to learn. So that's what happens in a optimization based control, where we actually use neural networks like fuzzy neural networks, which actually learn from the surroundings, and the reaction it gives to different action changes over the time. It will identify error, and each cycle it will try to improve itself. So that's why in future, in the coming days, people are trying to use neural networks and machine learning to create self-driving vehicles rather than using algorithms. So how do we leverage this problem with the available resources we have? So what kind of resources we have? If we have a closer look, we can see that there's a lot of hybrid vehicles in the market, and these vehicles have a big advantage over existing vehicles, because hybrid vehicles are vehicles that run on both fuel and electricity. And the second thing is that by making a vehicle be autonomous, it's actually using the existing algorithms and techniques to create the optimal condition and decide like when should the fuel be used and in what conditions should the electric motor should be used. So this decision to use the fuel or to use electric vehicle is actually on the algorithm or on the neural network that we are creating. And this decision plays a major role because it decides how far the car is going to run or how smooth the car is going to overcome different obstacles or different traffic conditions it's going to meet on the way. So that shows that a great importance that the neural network or the algorithm that we are designing is having on the performance on of the car. So the next is like what kind of improvements or output do we get from doing all this optimization by developing algorithm or by developing neural network? As you can see that the first major opportunity or the first major positive gain is lower emission, which comes through optimization of traffic flow and also by reduction of fuel consumption. The second one is a big change in the way how people use car will happen, because at present senior citizens and disabled people are not able to drive because they are not confident to drive the vehicle in the traffic conditions. But if self-driving vehicles come on stage, then these people will also be able to access driving. The third one is accident reduction, which means that the sensors that we have in the car will actually act as a means to reduce accidents, because most of the accidents happen today because of the negligence from the driver's side. So by handing over driving to a computer or to an algorithm, we are actually reducing that risk. Second one is increasing traffic density, which means that vehicles will be able to drive behind each other in a very close proximity. In that way, more vehicles could be accommodated in the current road infrastructure we have. The fifth one and the last one is increased fuel efficiency, which means by optimizing how we use fuel and also by optimizing how we use the electricity in a car, we are actually reducing the fuel consumption in the car. So that is a big thing to do because in that way, fuel emission could also be reduced. So the next one is how do we create a synergy between autonomous driving and energy? Which means that what is the output that we are going to get by clubbing artificial intelligence, machine learning, neural network, and self-driving in a single page? The answer is quite simple. It's autonomy. Autonomy means we are able to have an efficient driving style, and also we are able to have a safety and collision avoidance. We are able to improve our multimodal transportation system, and also in this case we can use data as a service, which means that the large amount of data that is developed from a self-driving vehicle could actually be used to identify the driving pattern, could actually be used to identify how this particular person is driving his or her vehicle, and then that could have further influence on like vehicle insurance, on the data that's available to the government to decide what kind of road infrastructure is needed in different place. So that is also a point to be considered because when computer engineers are designing a software or when you guys are building a software network, there will be a lot of data that is collected as part of the system. And this data could actually be used as a service to a different client, which means this data could actually be used as an opportunity to improve the service that we provide to the customer and also to provide new products to the customer about which the customer might not be having a clear idea at this stage. So that should also be considered as a major point in this case. So at the end of the day, um, when we do all this analysis, we come up with few topics or few cases in which currently there is not much research happening across the world. And these are the topics that actually computer engineers or software engineers could actually concentrate on, and they could try to develop future research papers or try to research in this field to actually improve the self-driving vehicle ecosystem. So first gap that we can identify is not having a deep research in energy management of autonomous vehicle, which means that across the world, people are trying to develop self-driving vehicles, but there is a clear lack of research in energy management of self-driving vehicles. So that is an opportunity for people who have interest in this field, who want to come into self-driving field, can actually start by doing a research into how self-driving vehicles manage their energy. The second one, or the second topic that actually could provide an opportunity for people to do a bit of research is the potential benefit autonomous vehicle framework could provide in terms of additional data to energy management system, which means that how can you create a kind of a cloud computing framework that provides a processing capability to autonomous vehicles or self-driving vehicles. So that is also a very important field. People who want to do research in self-driving vehicle field could actually try to create a network system that could actually help to improve the processing time of data that is collected by self-driving vehicle. The last one is a potential improvement in energy efficiency in self-driving or autonomous vehicles by the introduction of vehicle-to-vehicle communication and vehicle-to-infrastructure communication, which means that if you're driving through a road and if you're able to know that a red light is going to come in the next 1 to 2 kilometers, then instead of accelerating through that red light, you could actually start reducing your speed before reaching the signal. So you are saving a lot of time, and also you are saving fuel by maintaining a constant acceleration till you reach the signal. So to do like that, you have to develop an algorithm or you have to develop a neural network that provides an opportunity for the vehicle to communicate with the signal lights or with the traffic signals. So that is also a topic where people could actually do a bit of research and try to develop their interest in self-driving vehicle field. So my research team has actually completed a review journal paper on energy management of autonomous vehicles. We are actually trying to get it published probably in the coming months. And also we have developed a small Arduino-based robot, pretty small one, but actually we are trying to create a program. We have actually already created a program in Arduino, and it's like open software, so anyone can use it. And then you can actually create programs in Arduino and then upload that to the Raspberry Pi or Arduino hardware, and then you can actually see how sensors can help to create a self-driving vehicle feel in small-scale robots. So that could also be a starting point for people who are interested in this area to do a bit of research on Arduino, and also some open software would actually give you an opportunity to do a bit of coding and use that capability to see how data collected using sensors could be useful in supporting your programming skills. So that brings to the end of the slide. So the basic thing that I like to share with all of you guys is, if you have interest in self-driving vehicle field, the first thing you should do is you should try to learn how the data that the sensors collect from the surroundings could actually be used in different programming. So the best way to do that from my side is to use Arduino or some open software in which you can actually get some support from other universities or even from open research peer-reviewed papers, which might be able to provide you a bit of idea on how to use open coding to create programs and use that as a starting point to collect data from small-scale sensors. Yes, yeah, so that's the end of my slide. So if you guys have any doubt or have any comment to make on this, just pull through. Hello? Hello?
Yeah, Karthik. Now it's time
Yeah,
for
so
Q&A section. If
yeah,
anybody
so
having any doubts, they can raise their doubts in through text boxes.
yeah, so the basic thing is, like, I'm pretty sure you guys might be having access to Arduino or open softwares like that. Hello?
Hello?
Yeah. So I think like most of the students might be having access to Arduino or other open software. So
Okay.
the best way to go forward is if you guys can actually um, use that open softwares to code, then you can actually learn pretty much about self-driving vehicles through that. That's how my team approached the problem. We use open softwares to code and then upload that into Raspberry Pi or other small-scale hardwares, and then see how they react to that. Yep. So if anyone have any questions to ask, please, yeah, please type or share it in the chat.
I think nobody having any doubts, Karthik. We can move
Okay.
ahead. Okay.
Oh, yeah, yeah,
Thank
sure.
you, Karthik.
Yeah,
Thank
yeah,
you,
all
Karthik.
good.
Thank you for sharing your knowledge for us.
Yeah.
Now it's time to wrap out the session. Now I'd like to extend my sincere thanks to our CS department alumni, Kalpak CP, to arrange such an interesting session for us. Thank you all for being here today. The participation certificates will be issued soon, and we'll be back with another interesting session on tomorrow. Thank you.